Alright, sorry about that. So, we've got part two now of your root anatomy. So, I was talking about the different sides of your endodermal cells. We're talking about the Casparian strip that were on those transverse and radial walls, or the top and bottom sides of your walls, and then the right and left sides of your walls. Remember, the front and back are called tangential walls. Okay, so what that's what it's gonna. So yeah, that's just gonna create that super in there. So, and that's just called your Casparian strip there. That's found in the endodermis. The picture below that set of three cubes is kind of showing you that Casparian strip in terms of where it is in relation to the cortex and the epidermis. So, just kind of, I hope I've drawn that well enough. So, all right, so now we're going to kind of talk about the difference between the dicots and the monocots and their main differences in their structures. So flip your page back over to where you see the root apical meristem. Okay, so you can kind of see all those pieces that we talked about a little bit ago. You've got that epidermis there going around the outside. From that, you can see the root hairs. Then the cortex is there on the inside. That's going to be between the epidermis and your endodermis. And remember, that's where your Casparian strip is. Then that inner layer is the pericycle. Then, and I drew it, and then I figured out that I couldn't really see what was inside. So I don't know how well you can see that, because there's lots of little tiny cells. But that's your vascular tissue on the inside there. So if you look, you can look there or at the bigger picture. I'm not really sure, whichever you can see better. And on the inside there, that I only filled in on the right, the picture on the right, the blown up part of that. I only filled in one of those structures, but then I kind of filled in part of the top left structure there. But it's this particular picture it's got xylem there in the middle, phloem on the outside, kind of. And this particular structure is called a tetrarch because it's got 4 arms. You can have a diarch or a triarch, depending on how many arms you want to have coming off there. But this particular one, I drew a tetrarch. Okay, so you've got that solid core of primary xylem there. The cells there in the middle of that tetrarch, those are your that's going to be your metaxylem. And then I've drawn smaller cells kind of in the actual arms. That's your protoxylem. Okay. Now, in between the arms is going to be your phloem. Your metaphloem is going to be closer to the protoxylem, and then there again, I try to draw those as larger cells, and then your that's your metaphloem. Your protophloem then would be toward the outside nearest to the pericycle, smaller cells. And so yeah. And then you've got a row, or not really row, but a line, I guess, of a row of undifferentiated procambial cells found between, that kind of surrounds those arms. It's going to be found between your xylem and your phloem. So that's what your dicot root is going to look like. Then if you want to flip the page, your monocot root is going to look a little less crazy. The monocots usually generally look a little less crazy. With this one, you're going to have alternating bundles of xylem, primary xylem and primary phloem. You still have your root hairs coming out of your epidermis, not your endodermis. Still got that layer of cortex right underneath your epidermis. You got the two layers that surround your vascular tissue, endodermis on the outside. Still have your Casparian strip. You still have the pericycle there on the inside. And then you've got larger bundles of xylem, smaller bundles of phloem. And then to the right of that, I drew kind of that that structure there. So we've got, again, they're going to be in contact with each other. You're not really going to have that row of undifferentiated procambial cells. So you still got your protoxylem and your metaxylem and your protophloem and your metaphlloem. The protoxylem is going to be towards the outside. The metaxylem would then be towards the inside. And then you've got your pith. And that's your bundle, basically, right there. So, like I said, they seem to be, monocots in general seem to be a little more simpler structure-wise. So, they also contain a pith. So, unlike your dicots. So, I guess technically your ground tissue meristem would make your pith in this case. I know I said earlier they didn't have those, but monocots do. All right. We're gonna look now at your how water kind of gets through, which is why we went into the tangential, radial, and transverse walls. So water is going to enter through your root hairs. So we're on the back side here of your diagram. So if you look at the very, very bottom, that last one that we were talking about, the Casparian strip there. So you can see I've drawn that water goes through your epidermis, or your root hairs there. I didn't label the root hair, but I think you know what that structure looks like by now. So we've got water coming in that way. It's going to then go through the cortex. And then it's going to enter the endodermis. So, so this is where the tangential walls, remember that's the front and the back. Okay, so your tangential walls do not produce that suberin. Okay. If you recall back from osmosis, this was a long time ago, but charged and large molecules do not get past the cell membrane. So they have to actually go through the cell, kind of like through the proteins there. So this produces a type of transport which is called apoplastic or apoplastic transport, which I'll talk about here in just a second. So, like I said, it forces them to go through the tangential side. Okay, I'm going to skip the two types of transport. We're going to go to the next one, then we'll come back to the transports. So, if you look at that picture down at the bottom, the way that it's oriented, you can see that your Casparian strip is kind of running parallel to your epidermis. Okay, so that's why water is going to go through your tangential side. Okay, so once it gets in through that plasma membrane, what's going to happen is it's going to pass through that cell's cytoplasm. Okay, then it's going to go past the tonoplast, which is like the membrane of your vacuole. Then going to go through your vacuole, all the way through the vacuole, and then out the other side of the tonoplast, on the other side of the vacuole, through the other side of the cytoplasm of that same cell, through the other side of that plasma membrane. So we're going directly straight through. You can visualize that. And then out side of that cell, water is going to flow directly through. So plasma membrane, cell membrane, cytoplasm, tonoplast of one side of the vacuole, through the vacuole, outside the other side of the tonoplast, through the other side of the cytoplasm, and out through the plasma membrane through the other tangential side of the cell. Then it hits the xylem, which is going to move that water up through the root, up to the xylem of the stem. Okay, so that's how water is going to travel through your roots and up. Okay, so the difference between, now going backwards, going through apoplastic and symplastic transports, two different types. So in this case, you're trying to, apoplastic, they're going to try to maneuver from cell wall to cell wall through the intercellular space. Which happens to be more efficient. So that's one way water can travel. And then the other way water could travel is if it's forced to go through the plasma membrane, through the cell. It's going to be symplastic transport, which is when it goes from protoplast to protoplast. So your very last picture that I've drawn you there kind of shows you the two ways, because through symplastic transport, it's going to go through the plasmodesmata. So it's actually going to go through the cell and then go through the plasmodesmata between them. So I've labeled the two different ways that it can go through, either apoplastic, kind of around the cell, doesn't actually go through the cell, which, like I said, is more efficient. And then you can go symplastic, which would be going actually through the cell. So those are the two ways that water can travel in your roots. So that kind of finishes out your root anatomy. Tomorrow we'll hit the root modifications. So kind of like last time, the stem modifications we were able to put in with the stem structure, but this one is a little more, there's a little more, so we're splitting it up. So you'll do just root modifications tomorrow. So as always, if you have any questions, please don't hesitate to ask, and have a good day.